Welcome to the world of geometry. All right, here we go. We're going to look at section 7.2, and the title there would be Similar Polygons. Okay, again, we have some vocab to cover, so I'm going to cover that first. And the first vocabulary term being this right here. Okay, if we have similar polygons, there are certain rules in mathematics in order for us to say, hey, those two polygons, they're similar. So in order to actually say that and have it be true, two things have to happen. So two polygons are similar. So they are similar. And the mathematical symbol for that is this. Okay, that's the symbol for that so that we don't have to write similar. So similar polygons can only happen if there are two things that have to happen. Corresponding angles are congruent. They have to be exactly the same, people. Okay? Corresponding angles need to be exactly the same. If that does not happen, no, they are not similar. Okay? All right, second thing that has to happen. The lengths of the corresponding, popular word in similarity, sides are not congruent this time, okay? Because then they would be congruent polygons. In order to be similar, corresponding angles are congruent. Lengths of corresponding sides are, starts with a P, R, O, P. Do you know what I'm going to write out here? Proportional. Okay, and we just covered what proportional means last section. Could you define it right now, out loud? Say something. I don't think you guys said anything, but I could be wrong. Maybe you did it. Proportional relationship is when you have two ratios that are equivalent. So we're making ratios with the sides, the corresponding sides, and seeing if they're equivalent. That means they're proportional. Okay? All right, some other terms that we have to cover before we actually start doing some problems, because I have a lot of problems, people. Math problems. Okay. Another idea that comes up that we'll use is an extended, we talked about extended ratios yesterday. Now we're going to talk about extended proportions. So we know a proportion would be something like A over B equals C over D. An extended proportion, you're right, it's extended. It could then equal E over F. Okay? It could just keep going. So dot. Extended proportion. That's when you have three or more ratios that are equal. Okay? All right, next term. Let's get this figured out. Okay, one that confuses a lot of people. It's known as the scale factor. Scale factor. We use the term scale factor, I'm going to put in parentheses, when you have similar polygons going on. Okay, because if I got similar polygons, I'm probably going to ask you what the scale factor is. So the scale factor is, it's a ratio. That's all it is. It's just a ratio of the lengths of the corresponding sides. And if you remember, in order for similar polygons to be similar, the lengths of the corresponding sides have to be equal. Or, no, sorry, they don't have to be congruent. Sorry, they have to be proportional. And if they're proportional, their ratios are equivalent. So we're looking for that ratio. What was it? What was the ratio that's remained constant? Okay. All right. Whew. All right, take a breather. That was almost all the vocabulary covered here. One other thing to touch on. Sorry, forgot about this little feature. We also go into, because we're talking about similar polygons, guess what comes up? Scale drawing. And why would that come up? Because a scale drawing is going to be like if I were to draw this school on a piece of paper, and I keep everything in proportion, then I have drawn it as what's known as a scale drawing. So all lengths are proportional to their corresponding actual lengths. You could also think of it with like a picture of yourself. If I put a picture of you up here, which that would have been cool, I should have done that. Put a picture of you up here, smiling, adorable. And then I took it and enlarged it so your face was now this big. But I did it in a way where I made sure all the lengths were proportional to their corresponding actual length. So I did not distort your face. Okay, I kept it to scale. So one other feature with scale drawing is then saying, well then what's the scale being used? If I enlarged it, did I double it? Did I triple it? Did I just go up in size by 1.5, 1.5 times as big? So that's known as just the scale. So that's the ratio that compares the length in the actual drawing to, super important, the actual length. Okay, super important to get that part down. So it's drawing, my ratio is drawing to actual. Actual distance, drawing distance. And that ratio would be my scale that I would be using. All right, so let's actually start doing some problems. So now you're going to go to page 441. And you're going to go to the first got it problemo. And that's page 441. Got it. Problem number 1. Okay, so remember, pause the video. Try this thing out. Try not to get distracted. Stay focused. Stay on task, people. Okay, hopefully you pause the video because I'm starting. All right, got it number 1. It said DEFG is that means is similar to HJKL. And then it asks us, what are the pairs of congruent angles? Oh my gosh, there's no picture. How am I going to figure this out? How do I know, for one, that the angles are congruent? Because of this. They're similar to each other. So the angles, corresponding angles, have to be congruent to each other. Okay, I can figure out which ones are congruent just by this similarity statement. So I would say angle D is congruent to angle H. Does that help you? Angle D is congruent to angle H. And I'm going to use the congruency symbol there because I'm using the angles letters. I'm not just going to put equals because I don't have any numbers. And E corresponds with J. Then you have F corresponding with angle K. And then you have angle G corresponding with angle L. Okay? All right, now if I go to part B, and it's asking for the extended ratio, or extended proportion, sorry, for the ratios of the lengths of the corresponding sides. So I'm going to have how many sides? Well, there are 4 vertices, so I'm going to have 4 sides. So I'm going to have 4 ratios that are equal. And now it's just a list of a lot of letters. So let's look at DE right there. DE is going to be corresponding with HJ. Then I'm going to do EF corresponds with JK. Just as FG corresponds with KL. And then my last pairing is going to be D to G with H to L. Got it. Done. All right, let's go to got it problem number 2. So got it problem number 2. I have it here. Again, pause the video, try it out, see if you can figure it out, because I'm starting in. Okay, again, no cheating. Are the polygons similar? If they are, write the similarity statement and give the scale factor. So you're probably hoping they're not similar so that you don't have to do that step. But let's see, part A. All right, right away I check and see corresponding angles congruent. Done. Okay, second thing that has to happen. Corresponding sides have to be in proportion. So let's see, KL, that's the shorter side, corresponds with the shorter side over here, 15. Just as, I'm going to go over here to 15, corresponds with 20. Are these equivalent ratios forming a proportion? I would say, well, this one simplifies to 3/4, and this one simplifies to, because I divided both these by 5. Divide both these by 5, and I'm at 2/3. Same ratios? Nope. Woohoo! So I do not need to find the scale factor or write a similarity statement because they are not similar. Yay. Okay, second one, probably meaning that these are. Let's check. Are these similar? Well, let's check the corresponding angles. Boom, 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 boom. Yep, okay, angles are good. Sides, 9 goes with 18, just as 6 goes with probably 12. Those the same? Half and a half? Oh man, they are. All right, so I need to write a similarity statement. These things are similar. So I'm going to start with A and just go A, B, C, D, E. And you could have started with something else, okay? But then that means your rest of it is going to be a little different. And then is similar to. When I do this, I like to just look at the angles. So A corresponds with which angle over here? S. Then I go to B, which is 90 degrees, so I'm going to go to R. And then I go to C, which corresponds with B. Then I go to D, which corresponds with U. And then I go to E, which corresponds to T. So I have SRVUT is similar to ABCDE. And then it does ask to give the scale factor. The scale factor is going to be, if I start at, remember, scale factor is the ratio of the lengths of the corresponding sides. So if I start at 18, that corresponds with 9. Just as 12 corresponds with 6, which means my scale factor is 2 to 1. And you might say, could I have 1 to 2? Well, the way I wrote my similarity statement, I started with A, B, C, D, E, so I'm going to start here when I do my ratio, so it would be 2 to 1 there. Okay? All right, you guys are now trying got it problem number 3, and this is going to be extended into another video because I only have a 15-minute limit. So go ahead and try number 3, and that'll be the start of my next video. Okay? See ya, people. See you soon.